Hey everybody, I'm going to go over the answer key to the is it true task. And so this is in helper documents. And in the helper documents, you're going to see all the keys. And so this one is it true task? Let's see if I can move this up. By the way, there is a intro video to this task, so I hope you watch the intro video first before doing the task, and certainly before you check your answers with the key. So it should open up like this. And, it's important to understand that, I think the concepts are really important, but the wording is not. The vocabulary is important, but there's a lot of ways to explain this. And so there's a lot of correct answers. And your answers might be completely different by me. And if the reasoning is correct, then, as long as your answers are justifiable, then they're good. Okay. So Amy assumed that subtraction has a commutative property where like A minus B equals C, so it must be the same that B minus A equals C. So, we're talking about the commutative property. You can't flip the X and the 5 around. That's going to change it. If it were adding, you could flip it around. But 6 minus 5 is not the same thing as 5 minus 6. Just like 5 minus 1 is not the same as 6 minus 1. And then Ben's misconception is he does not know about negative integers. So while anything taken away from 5 is less than 5 is true if it is a positive number, if you take away a negative number, or so to speak, subtract a negative number, then you would in fact be adding, so you can get a bigger number there. So if you think about this as a solution, I think I worked it out. Yeah, minus 5 both sides, and then divide by -1. Remember that the negative in front of the x comes down, so it's negative x equals 1. Divide by that -1 there, and you get x equals -1. So the check is 5 minus -1 equals 6. And I would explain this as you need to subtract a negative number in order to get a higher value or a higher integer. That would be a really good explanation. And so there's a lot of good vocab words there. We use commutative property. We use negative integers or negative values. You can talk about inverse operations to solve. There's a lot there you could put. Okay, and then the next one is 8x minus 6 equals 2x. And Amy is correct about like terms. You need the same like terms in order to combine or subtract or however you say it. But in this case, you can solve for x because you can subtract 8x from both sides, or you can subtract 2x from both sides. And so, if you just had 8x minus 6 and you were asked to simplify, you couldn't simplify it. But because it's a linear equation, you can use algebra to, isolate the x. She doesn't answer the question in what value is true for x, because there is a true value for x. Bennett checked his answer for 3 values. His work is correct. He should know that there are 3 outcomes for this type of problem. So when you have the x on both sides of the equal sign, you can have one solution, no solution, or infinite solutions. And in this case, we're going to have one solution, and Ben found it. Here's the answers to the card shuffle. And when something is true, sometimes you have one answer. When things are true all the time, you have infinite number of solutions. And then when it is never true, you'll have no value for x that would work in order to make the equation true. So, okay, I hope that helps. So, I want to